Greetings everyone, I hope I find you well. Welcome to my YouTube channel. Thank you for supporting me and for your comments and for your views. This video is the last video I will do on logarithms. So I've tried to summarize some laws or most of the laws on logarithms in this single video, and also give a new example so that to enhance your understanding. Okay, so let's dive into it. So the title here says laws of logarithms summarized. Okay, so the first law which I'm going to deal with, it says log m plus log n equals to log m times n equals to log mn. Okay, sort of a product law. So there's an example here which says simplify log 9 plus log 6. So according to this law, log 9 plus log 6 becomes log 9 times 6, or 9 multiplied by 6, which is a product, so it gives us log 54. That's our answer here. Highlight with a highlight of a green highlight below it. Okay, another example also still on the first law. It says given that log 2 equals to 0,3010 and log 3 equals 0,4771, find the value of log 6 without using tables or without using a calculator. So based on the first law, log 6, since I was given the value of log 2 is 0,3010 and log 3 equals 0,4771, I'll combine this 2 and this 3 as a product. So log 6 becomes log 3 multiplied by 2. So according to the first law, the reverse of this one. So log 3 multiplied by 2 becomes log 3 plus log 2. But remember, the value of log 3 is given here as 0,4771, and the value of log 2 is given as 0,3010. So log 3 plus log 2 becomes 0,4771 plus 0,3010, which gives us this final answer is 0,7781. Okay, so let's proceed to the second law. So this law I just summarized with some examples. The second law says here log m minus log n equals to log m over n. As an example, log 16 minus log 4 becomes log 16 over 4, which is a log 4. That's our answer. Also another example, we are given that log 10 equals 1 and log 2 equals 0,3010. So we want to find log 5 without using tables or without using a calculator. So we combine this 10 and this 2 to give us 5, like this. Log 5 equals to log 10 over 2 based on this this law. Log m minus log n equals log m over n. So log 5 equals to log 10 over 2, which is log 10 minus log 2. Remember, the value of log 10 is 1 and the value of log 2 is 0,3010. These logarithms are in base 10. Okay, they are in base 10. That's why you don't see a base here. They are in base 10. So I substitute 1 for log 10 according to this, and I substitute 0,3010 for log 2. So it becomes 1 minus 0,3010, and our final answer will be 0,699. Okay, Let's move on quickly. Right. Third law, log of m to the power raised to the power x to base n. Log of m raised to the power x to base n can be written as x log of m to base n. So this power goes right here. So it becomes x log of m to base n. So here's an example. Log of 16 raised to the power 2 to base 3 becomes, this 2 here goes right here, so it becomes 2 log of 16 to base 3. Further, we can further simplify this 16. 16 can be written as 4 raised to the power 2. So this 2 will go again here. So finally, this 2 and this 2 gets here, multiplies this one. So it becomes 2 multiplied by 2 log of 4 base 3. And finally, our answer will be 4 log of 4 to base 3. Okay, let's quickly move on to law number 4. Here, log of b to base b equals 1. This one is called the argument. This one is called the base. If the base and the argument are the same, the logarithm of a base of an argument raised to the similar base is equal to 1. Okay, for example, log of 10 to base 10 equals 1. Okay, also let's move on to number 5. Law number 5 says log of 1 to base y equals 0. Okay, if your argument is 1 and the result is 0, the base here, it shows that the base, if your argument is 1, it means this base will be raised to the power 0. So in other, this statement can be read as raise base y to the power 0 to get this one, the argument 1. But remember, these conditions are hold for much of these laws. Your base should be greater than 0. As you can see, in this case, my y was the base. Your base always should be greater than 0. And also your base must be not equal to 1. Okay, this base, the base must not be equal to 1. In this case, it's y, and this base must also be greater than 0. For example, as you can see, my base here is 4, is not equal to 0, and is greater than 1. So log of 1 to base 4 equals 0. So if you raise 4 to the power 0, you get 1. Okay, let's move on. Right, here we are, law number 6. That's log of 1 over n raised to the power b. This one will be written as n to the power negative 1. So log of n to the power negative 1 to the base b. This power can then go right here. So it becomes minus log of n to base b. As an example, log of 1 over 4 to base 8. 1 over 4 becomes 4 to the power minus 1. So log of 4 to the power minus 1 to base 8, it becomes minus 1. Log of 4 to base 8. And then this 4 here can be simplified as 2 raised to the power 2. And this power here 2 will go here to multiply this negative 1 according to the rule which we touched earlier. So this 2 will multiply this negative 1 like this. So it will be multiplied with the negative 1, becomes minus 1 multiplied by 2 log of 2 to base 8. It becomes minus 2 log of 2 raised to base 8. Okay, this just summarized the version of the laws so that just a recap of what we covered previously. Okay, let's move forward. Law number 7, log of k raised to log of k to base x to the power y. Here, now our power, in this case, our power is on the base. This base x is raised to the power y. Okay, so what we do, we take the power of the base, in this case our power is y, and we say 1 over y log of k to base x. Okay, so log of k to base x to the power y becomes 1 over y log of k to base x. Okay, as an example, log of 3 to base 3 to the power 2 becomes 1 over 2. This 2 here goes below 1 over 2 log of 3 to base 3. But remember, as we saw before, that if the argument and the base are similar, the logarithm of a number which is similar to the base is same as 1. So half log of 3 to base 3 becomes half multiplied by 1, which is simply half, is our final answer. Okay, law number 8, log of a to base b can be written as 1 divided by log of b to base a. Okay, log of a to base b can be written as 1 over log of b to base a. As an example, log of 4 to base 2 can be written as 1 over log of 2 to base 4. This 4 can be simplified as 2 to the power 2, so it becomes 1 over log of 2 to base 2 to the power 2, and this 2 here can be written like this one can be written as, we take this power of the base and write it below 1 is like this half. So it becomes 1 over half log of 2 to base 2. Remember, log of 2 to base 2 is 1. So it becomes 1 over half multiplied by 1, which is the 1 divided by half, which is equal to 2. So our final answer will be 2 in this case. Okay, this will be our final answer, the 2 here. Okay, let's move on to the next sheet. Okay, law number 9, log of x to base b. Here, this one is called the logarithm change of base formula. Okay, the logarithm change of base formula, log of x to base b can be written as a log of x to another base. In this case, I was using base n. So it can be written as log of x to base b can be written as log of x to base n. You can use another base which you want, divided by log of b to the same base n again. Okay, like for example, I can say log of x to base b can be equal to log of x to base 10 over log of b to base 10. Log of x to base b can be equal also to log of x to base 5 over log of b to base 5. So these bases must be similar. Okay, as an example, log of 16 to base 4 can be written as the years using base 2. This one must be similar. You can use base 3, base 4, whatever. So log of 16 to base 4 equals to log of 16 to base 2 divided by log of 4 to base 2, like this. Which is equal to log of 2 to the power 4 to base 2 over log of 2 to the power 2 to base 2. Applying the previous laws, these powers will go right here. So it becomes 4 log of 2 to base 2 over 2 log of 2 to the base 2, and this one is 1, this one is 1. So finally it will be 4 over 2. If checking the previous encounters, this one becomes 1. So finally we are left with these ones. This one will cancel out. So we are left with 4 over 2, which is 2, and 2 will be our final answer. Okay, I hope you are following well and you are grasping the concepts here. Right, let's move on to law number 10, which says this one is combining the first law and the second law in this video. So log of a to base x plus log of b to base x minus log of c to base x equals to, these two are combined in multiplication here. This negative will be divided, so it becomes log of a to base x plus log of b to base x minus log of c to base x equals to log of a multiplied by b divided by c to base x. So it's a combination of the first law and the second law in this video. Finally, it becomes log of ab over c to base x. For example, log of 36 plus log of 25 minus log of 9 becomes the log of 36 multiplied by 25 over 9, which is log of 900 over 9, which is log of 100. Since you are dealing with base 10 numbers, log of 100 equals 2. So that will be our final answer. Okay, I hope you are grasping the concepts here. So finally, I want to give you a challenge. Okay, I want you to attempt these questions. It's just a call to action. Attempt these questions and see if you have grasped the concepts which I shared in this video. In this video, by the way, is my last video on the laws of logarithms. We are moving on to the next topic in the next videos. So I will leave you with a challenge here. We will meet in the comment section, go through these questions and see if you have grasped the laws or the concepts on logarithms. I thank you for your support and for your views and your comments. Thank you. See you in the next videos.